Today I have a very special guest. It's Dr. William Harris. He holds a PhD in nutritional biochemistry, and his research has focused on omega-3 fatty acid. He has published more than 300 papers in the area. And actually in 2004, he developed the Omega-3 index. I'm quite sure all of you know this Omega-3 index. It's a very, very valuable tool for all of us working in the Omega-3 field. And in 2009, he formed Omega Quant Analytics, a company which offers tests to the researchers, clinicians, and consumers. In 2020, he started the Fatty Acid Research Institute to accelerate the discovery of fatty acids and health relationships. His scientific productivity was recently ranked among the top 2% in a survey of scientists worldwide. Well, Bill, I'm very, very happy to have you with us today, and thank you very much for sharing your time. Hey?
Yeah, my pleasure. Thanks for having me.
Great. Well, so let's just jump into the first question. What was actually your first professional contact with omega-3 and when? So how did you get into contact with this subject?
1979 was my first professional contact. I was a new postdoctoral fellow in the laboratory of Dr. William Connor in Portland, Oregon. And I had finished my PhD in Minnesota in nutrition, and I was pursuing, of course, advanced studies. And so I got to be with Bill, and he was interested in the effects of different kinds of dietary fats on cholesterol levels. And we knew at that time that saturated fats, hard fats, and that came from animals would raise cholesterol levels. And we knew that vegetable oils, which liquid oils, would lower cholesterol levels. So Bill was curious about fish oil because it was an animal oil that was liquid. So the question was it sort of the liquidness of the oil that affected cholesterol, or was it the animal versus vegetable source that so fish was kind of a nice, here's an animal with liquid oil. So we organized a metabolic feeding study. He had me do this and fed healthy volunteers. Probably in the neighborhood of, it was around 25 grams of EPA and DHA from salmon oil. They were drinking about eating 40% of their calories from salmon oil.
Oh,
so far more than Eskimos ever thought about doing. Okay, so it was huge. And we did 4 weeks on that, 4 weeks on a vegetable oil based diet, and 4 weeks on a saturated fat diet. And we found that cholesterol levels did go down. These were normal volunteers, so they were not hypercholesterolemic. It went down as much on the vegetable oil diet as the salmon oil diet.
Okay.
But what went down in the salmon oil diet uniquely was triglycerides. They did not drop with the vegetable oil diet. So that was kind of our first peek into the triglyceride lowering effects of fish oils.
Okay.
And really at the time, honestly, was not aware of Dyerberg and Bang's work in Greenland. Even though their third paper on the topic was published in '78, it had missed me. I was, just thinking about more cholesterol and not omega-3s.
Okay. And so you guys were actually one of the very first ones who ever saw this relationship between fish oil and triglyceride lowering effects. Is that correct?
Right.
And from there, how did you actually get to the omega-3 index? I mean,
well, for about 20 years, I was studying really the effects of fish oil on lipid and lipoprotein metabolism. And so we did a lot of supplementation studies. We did metabolic turnover studies. And it was in 2002, at American Heart Association meeting that I was with Clemens von Schacke, a German cardiologist you probably know, a friend of mine, and we were listening to a presentation by Christine Albert from Harvard of the omega-3 levels in the blood predicted risk for sudden cardiac death. prospective study that showed that the higher omega-3 levels in patients or people who were healthy volunteers when the blood was drawn, higher omega-3 predicted lower risk for sudden death. And this was fascinating to us. And I remember Clemens and I were having a beer after this presentation in Chicago, and we said, the omega-3 levels in the blood mean something. They really are, they carry information, risk information. And it's not just a measure of how much fish you eat, which is the way it's kind of been used in the past, but it actually is prognostic in the same way that cholesterol or blood pressure or diabetes are prognostic for future disease. So we said, somebody ought to measure this thing. We ought to, how about I'll set up a lab in the US, you set up a lab in Germany, and we'll offer this test to doctors. And that was the beginning of it. It took us about 2 years then to write a paper.
Okay.
In 2004, proposing what became the omega-3 index. We made up that name.
Right.
Blood cell, EPA, DHA. And then we laid out the rationale in that preventive medicine paper as to why this made sense and what the target values ought to be.
Yeah, I mean, for me, also in my professional life, this was a very, very helpful tool all the way through. Also to understand, I'm not sure if I can say this or not, but basically what I see in the omega-3 field, you have many studies which have like contradictory results. But I think also in at least some of these cases, one of the problems is that if you have already a omega-3 index, which is in the beginning of the study quite high, then an additional supplementation will not really show so much effect anymore, right?
Exactly.
But, coming back to the omega-3 index, how did you actually get the idea to measure the omega-3s in the red blood cell membrane and not just in the blood? I mean, just in the serum. There's a big difference.
Right.
There, right?
And that went back to a study published in the mid-90s by David Siskovic in JAMA, where he looked cross-sectionally at the relationship between red blood cell EPA DHA and risk for sudden cardiac death. And this was a study in Seattle, Washington. And they collected blood samples from people who were actually having a heart attack at the moment. They got the paramedics and the ambulance drivers to draw blood from people that they went to assist when they were having a heart attack. And so they got blood at the time of the heart attack. And they chose to measure red blood cell EPA DHA. And I don't remember exactly why they chose that, but we got that in our head that kind of like hemoglobin A1C for diabetics. It's a long-term stable biomarker of omega-3 status. So we settled on that. In Dr. Albert's paper at the American Heart Association that got this idea going, she measured whole blood EPA DHA, but those are all very highly correlated with each other.
Right.
So we settled on red blood cells, probably because of the David Siskovic paper from JAMA.
But it also makes sense, I believe, right? Because it's a long-term value,
makes sense
right?
too.
I mean, it's really a long-term reflection of basically your diet, if you like, right? Because it's
yes. Well, and it's a cell. I mean, that's an important thing. We wanted to measure cell membranes.
Yes.
And that's the easiest membrane to get at in the body.
Yeah.
So we picked that as well. And we knew that correlated with cardiac omega-3 levels, and have since learned it correlates with a lot of different tissues and their omega-3. So it's a great reflection of the body in general.
Right. Now, the definition of the omega-3 index, does it actually include the DPA? So is it EPA plus DPA plus DHA, or is it just EPA plus DHA?
It's just EPA plus DHA, because that's what it was originally, and we took it. There is, we now know that there are more roles for DPA. I'm sure there's still a lot to be learned about DPA. Originally, that was not in the picture. Dr. Von Schacke and I wrote a paper a couple of years ago entitled, "Why is DPA not in the omega-3 index?" So, because this question has come up, obviously. So we basically used it, looked at the risk prediction for total mortality in one of the big cohorts that we done, and we knew that their EPA plus DHA was a predictor of risk for death. In this one cohort. We then redid the analysis by adding DPA into it. And DPA didn't add any predictive value. It changes the actual number of the omega-3 index, but it just changes it by a fixed factor. It goes up the same amount all the time. And so it doesn't give you any more prognostic information than EPA and DHA do. Plus EPA and DHA really track with fish intake and DPA does not.
Yeah. No, I could imagine that it actually just increases the overall number as such, right? The overall concentration, if you like, if you add DPA.
Right. But the real important question is, can you predict risk any better?
Yes.
And we can't.
Right.
So that's plus. Then you get into the practical question of, now we've had a metric out there for 17 years that people have gotten used to the numbers, and we say, oh no, the target value instead of 8, now it's 11. Right. Because we've added DPA.
No, that just brings too much confusion into the.
Yeah, we got enough confusion in this field as it is. So.
Yeah. Now, from your experience, what omega-3 index would you actually recommend, or where should you be to have a healthy index?
I think we originally proposed 8%, so 8% of red cell fatty acids as EPA plus DHA. That was what the evidence up until around 2004 was pointing to. In the years since that time, we've been able to test that, and pretty much holds up quite well. In fact, a paper we'll talk about, we published just yesterday, a large paper with 17 cohorts using blood levels of omega-3 to predict risk for death. And we had, over 45,000 people in this, and we had, like I said, 17 cohorts around the world were involved. Okay. With a follow-up of about 16 years. But we found in that study, when we compared the level that was associated with the lowest risk for death, was about 7.7%. Okay, and the level that was associated with the highest risk for death was about 3.5%. So our original proposal back in 2004 was under 4% is where you don't want to be, 8% and above is where you do want to be. And so I think that's pretty good evidence that target of 8% is still a good target. 7% is good too, but not quite as good as 8.
Right. When I was living in the US, I made a study. I had a study with the University of Ithaca with sports students. And it was amazing. We started off also measuring the omega-3 index at the beginning of a study. And the average was actually at 3.65. So relatively.
Oh, were they all vegans?
Very low, isn't it? I mean, for sports students then?
Those sound like either US soldiers or vegans. But that's low.
It's low. And do you know, from your experience, what would you say is the average omega-3 index in the US population? Where would you see that?
I'd say it's around 5.5, maybe 5.5 or so, somewhere between 5 and 6. And every time we look at it, we see something like maybe 5% of the population, if we're lucky, have an omega-3 index over 8. Okay.
That's also still very small.
Still very small.
If you eat a lot of fatty fish, or if you supplement yourself, the omega-3 index would go up, but does it reach a certain maximum level? Is there a saturation point? Or
there seems to be. Nobody's really done a saturation study that I know of where you'd give 2 grams, 4 grams, 8 grams, 16 grams, and let the omega-3 levels settle. What we hardly ever, in hundreds of thousands, we rarely see anything over 16%.
Yeah.
You know, once in a while we've seen a 20%, which is just out of the, but it doesn't get higher. I mean, that's as high as dolphins are. I mean, and dolphins eat omega-3, eat fish all day long. And
okay, you could expect that's more or less the average.
I think
the highest.
there is I think there's a physiologic limit that the body only puts so much omega-3 in a red cell membrane.
Yes. Which probably also makes sense, right? Because if it really gets so much, I think it would also go on behalf of the stability of the whole cell, right? The fluidity might be just too big then.
Right.